Hi guys, this is my first project as an intern in data science in Sparks Foundation. So my first task is to predict prediction using supervised learning. So as a first step, we have included many libraries like Matplotlib, Pandas, sklearn. In sklearn also we have imported linear regression. So these all libraries are gonna use we are gonna use. Now as the next step we have to load the data. So this is the website from where we have loaded our data, and to check our data frame we have used df.head, and you can see here it consists of two columns, hours and scores. Now next part is df.info. I have used it to get the knowledge of data frame. So here you can see it consists of 25 rows and 2 columns. Here you can see the data type of each column, how many null values, and the memory usage. Now the next part is df.describe. This part basically, this function basically gives us the idea about statistics part of the data frame or data set, like count, the mean of the columns, the standard deviation of the columns, minimum of the column, maximum of the column, etc. Now we have to visualize our data frame with the help of matplotlib. So as the matplotlib graph, here you can see, we can simply assume that the correlation between percentage of the score and R studied is linearly varied. So it is better to apply linear regression in this data set. So, and you can also, to customize this graph, you can use here color as you wish, and you can change the style here to change it rather than star to circle one. Now the next part is preparation of data. So we have to separate from data frame the dependent variables and the independent variables. As we have done, x is the dependent variables, y is the independent variables, and now we are again distributing it into two parts, two sets, training set and the test set. So we have used this train test split library, and you can give this value as you want from 0 to 1, but it's better to give between 0 to zero point 0.4 or zero point 0.3. And so here you can see the data frame of x train, x test, and y train and y test. So x train consists of 17 rows and one column, x test consists of 8 rows and one column, y train consists of 17 columns and one 17 rows, 17 rows and one column, 8 rows and one column. Now as this are split into training set and test set, now we have to take the training set and train our model. So we are using here linear regression, and here in the one step you can just complete the training. Now to build the line, you can use regression.coefficient or regression.intercept. So you will get slope and intercept of the line, and using y and slope into x plus intercept formula of a line, you can just build a line. So to see it visually, you can see it here. These are the variables and the data frames we have, and this is the line which suits all of them using this regression. So using this linear regressions. The green line here is the linear regression line. Now, as our data is trained and model is trained, so we are ready to make the prediction. So you can see here the number of hours studied by the students in the test set. Now to here the prediction are stored in y predict variable. Now we have the original scores, and now we are using this predicted scores. So here you can compare the scores predicted by our model and the actual scores which are present. The best way is to check the accuracy is using regression dot score function, which gives us the accuracy or gives the comparison between the actual set and the predicted set. So you can see here training set got an accuracy 95% and testing set accuracy here we got 94%. So it is better to get above 90 for better predictions. Now as an example we can use our prediction for own data, like suppose the prediction of the score of the student who studies 9.25 hours daily. So you have to put that 9.25 in the 2D array, and you can see here the own predict variable contains the prediction, and you can see here 92.6 percentage is our prediction for the student who studies 9.25 hours a day. Now the most important and the last step of our model building is comparing the algorithm with the other. So how well your algorithm has performed in this particular data set is very important. And to find a way to do that, you can use import metrics library from sklearn, and in that you can use mean absolute error function to uh, get the idea about your algorithm. So it is better if you get this value between 1 to 6, and you can also use mean squared error for variations of data. Thank